In the second part of the 6.3 video, we are going to be graphing these exponential functions. You're probably going to want to use an input-output table. Let's use the typical -2 to 2 domain values. And then all we're doing is what we did in the section just above, where we're taking this x value and substituting it for x and evaluating. But before I do with this first one, let's put that into normal exponential function form. So remember that normal exponential function form is a times b to the x. So this first one doesn't define a. There's just a negative in front of the 2 to the x. So I would look at that as -1 times 2 to the x. So we're not doing a -2 to every power. We're doing 2 to the raised to each exponent and then multiplying by -1. So you could do this the short way to get each y value, but I would rather just type this into my calculator probably. I'm going to start with 0 and go from there. So 2 to the 0 is funny. If I do 2 to the 0 power, my calculator tells me it's 1. As a matter of fact, any number to the 0 power always equals 1. That's just a property of exponents that you should probably know. So our first y value then would be that 1 times -1. So -1 times 2 to the 0 power, that's -1. So our first y value is -1, which means we're graphing the point 0, -1. So that's right here. Our next y value would be -1 times 2 to the first. Well, 2 to the first, that is 2, and 2 times -1, we should get -2. There we go. -2. And then again, for when x is 2, 2 to the second means 2 times 2. That's 4. 4 times -1 should be -4. There we go. So we have these points, 0, -1, 1, -2, 2, -4. So those we can plot on our graph. And then working back way, well, I know going this way is multiplying by 2. So that was times 2 times 2. If I work backwards, divided by 2, divided by 2, divided by 2, we should get -0.5 or -1/2. -1 times 2 to the -1 power is -0.5. And if I divide by 2 again, I would get -0.25. So there's my other 2 points. And then I can draw my curve, make sure it does not cross the x-axis, and then it's going to get really steep. So there's my graph of that first exponential function. We're never going to cross over the x-axis here. That is like a line that we can't go across. It makes sense that we're growing in the negative direction because our a value is negative. And we have a larger than 1 base, so we're growing. So these negative exponents, they are actually indicating that we're not multiplying by 2. The negative exponent means that you're dividing by the base. So that'd be a good note to add here as well. And then give number 9 a try as well. So here's my values for y using the equation in number 9. I started at the bottom of my table. I used 2 times 1/4 to the x, or 2 power. So that means I'm multiplying 2 twice by 1/2, and that gave me 0.125. So that's this little tiny point right there just above the x-axis. 2 times 1/4 to the first power just means 2 times a single 1/4. Sorry, that should have been a 4. 1/4 to the 0 power is 1, and 2 times 1 is 2, and then I just kept working backwards. So these negative exponents, again, remember negative exponent means dividing by b. So for this one, for example, I was doing 2 times 1/4 to the negative 1. So this means that we're doing a or b divided by 1/4 one time. So 2 divided by 1/4 is 8. Also 2 times 1/4 to the first is, oh, I was supposed to do negative 1. To the negative 1 is also 8. 2 times 1/4 to the negative 2 is 32, because if we do 2 divided by 1/4 once, twice, we get 32. So that negative exponent means you're dividing by b. All right. So finally with this, when you are talking about the domain and range of these graphs, remember, domain refers to all the x values, and I've got arrows going here. I could keep going with my table. Domain for these exponential functions is always going to be all real numbers. There's no limit to what x values I can use. And my range here is, what are the possible y values? Well, I'm never going to switch back to positive, because every time I use an x value, I'm multiplying by -1. So all of my values will be negative. So this is always, my y values are always less than 0. What about for number 9? The domain, again, is always all real numbers um, for these exponential functions, and the range would be, where are my y values? They're all on the positive side, so that is always y greater than 0.